All right, let's jump right into this explainer. Today we're tracking a really fascinating journey of frustration, learning, and finally total clarity. We're diving into the notes of a dev named Aang who recently had a massive breakthrough with Haskell. Now, if you've ever banged your head against a notoriously complex programming language, you know exactly how daunting that initial climb is, right? But man, that moment when everything finally clicks, it's absolutely unbeatable. Aang actually captures this struggle perfectly in their 133rd entry on Haskell programming, saying it took many moons to get used to how Haskell works. Welcome to the steep learning curve. It's a feeling every focused learner knows intimately when tackling functional programming. It just doesn't happen overnight. It takes serious time, patience, and honestly, a whole lot of trial and error to rewire your brain to a completely new paradigm. So, moving into our first section, the Haskell breakthrough, when the types finally align. And that brings us to the specific catalyst. Section 2, the code that clicked, a literal 2-line code diff. Okay, so take a look at this. We rarely get to see visual proof of an aha moment, but here it is. Notice how that clunky verbose block on the left just seamlessly collapses into the incredibly elegant single-line function on the right. In that before state, Aang had written out a whole do block. They were explicitly extracting a result from parse_li, dumping it into a variable named _result, and then manually returning pure OK just to satisfy the program. Sure, it worked, but it was noisy. Then, look at the right side. The exact same operation, totally reduced down to simply main equals parse_li. That single diff right there, that is the precise instant Aang finally grokked, or intuitively understood, Haskell's type system. It's like the training wheels suddenly came off. Aang realized they no longer needed to manually wrestle the code into the right shape, because they finally, truly understood how data naturally flows through Haskell's strict parameters. So why exactly was this transformation possible? Well, it all comes down to I/O function. Aang realized exactly how the parse_li function returns an I/O function, and crucially, how that fits perfectly into the main entry point. Because main is fundamentally expecting an I/O function, and parse_li already is one, all those extra manual steps were totally unnecessary. The types were already in perfect alignment. Which leads us to Section 3, Bridging Programming Paradigms, from Haskell to System Languages. You see, mastering Haskell isn't just about learning Haskell. It's really about unlocking a much broader comprehension of software architecture as a whole. Aang notes that immersing yourself in this hyper-strict environment actually becomes a huge help when you switch back to other languages. There's just this deep, deep satisfaction in seeing type system concepts suddenly click across completely different programming paradigms. Just think about heavy system programming languages like Rust, Go, D, or Ada. Aang specifically points out that this hard-earned Haskell knowledge pays massive dividends when diving back into pet projects built in those environments. That intense strictness that initially felt like a huge hurdle in Haskell, turns out it's a universal architectural concept that these heavy system languages also rely heavily on. And here's how this actually plays out in a practical, real-world workflow. Step 1. Aang had previously bootstrapped some ad hoc Go and Rust projects using AI. Step 2. Aang takes a massive detour to immerse themselves in Haskell's strict types, enduring that notoriously steep learning curve we talked about. And then Step 3, the big payoff. Aang can now look at those AI-generated Go and Rust projects and actually comprehend them just by reading the raw source code. That Haskell detour literally rewired their ability to read and understand other type-heavy codebases. Wrapping up with Section 4, the Yearly Language Challenge, a philosophy for continuous learning. This entire experience really culminates in a powerful philosophy for any serious developer. As Aang beautifully summarizes it, after all, learning one programming language each year proves to be a fun and insightful journey. Look, the learning curve is steep, no doubt about it, but that cross-paradigm payoff, it's deeply satisfying, it keeps your mind flexible, it exposes you to completely new logic structures, and ultimately it just makes you a much better programmer in the languages you use every single day. So as you reflect on the journey we've just unpacked in this explainer, I want you to consider your own development path. The evidence from Aang's experience is crystal clear. The struggle is absolutely worth it. So if learning one new programming language a year can fundamentally transform how you read and write code, which complex paradigm are you going to choose to conquer next to reach your own aha moment?